I think what I want to do first of all is start off with a concrete example, and then I'm going to tell you what a prime number is and what a composite number is. It'll be way easier that way. So let's talk about first the concept or the factors. So let's find the factors of the number 3. The number 3 is a nice little tiny number. We are very comfortable with it. 3 is not scary. 3 is not big. It's just a number 3. What do we say when we say factors of 3? What I'm saying is, tell me all the numbers that multiply to give you 3. Now, 3 is so small, it's easy to think about. What can possibly multiply together to give you 3? Well, there's only 2 numbers that work. 1 times 3 is 3. That's it. There's no other numbers. If you try to pick 2 and say 2 times what is 3, doesn't work. 2 times nothing doesn't work. It doesn't give you 3. If you pick numbers bigger than 3, 4 times something doesn't really give you 3. 5 times something doesn't give you 3. 10 times something doesn't give you 3. The only numbers that multiply to actually give you 3 are 1 and 3, because 1 times 3 is 3. So the factors of 3 are going to be 1, because 1 times 3 we know is equal to 3, right? Because we know that 1 times 3 is 3. Then we know the factors are, we'll just write them down. 1, actually I should have put the 1 first here, sorry about that. We'll put the number 1, comma, 3. These are what we call the factors of the number 3. 1 and 3 are the factors of 3 because they're the only numbers that work to multiply to give me 3. All right? Now the other thing I want to do is now introduce the idea of a prime number and a composite number. If a number only has factors that are the number 1 and the number itself, then we call it a prime number. So the number 3 is a prime number. I'm going to write that down in a different color because that's part of the answer. We want to write down the factors of the number, and then we want to tell if the number is prime or composite. This is a prime number. So I'm going to kind of circle both of these because they're both part of the answer. Part number 1 is what are the factors of 3? And we give the answer of 1 and 3. Because 1 times 3 is 3, and those are the only numbers that multiply to give me 3. And then we say this is also a prime number. 3 is a prime number. Why do we know 3 is a prime number? Because the only factors that work are the number itself, which is 3, and the number 1. So if I tell you, if you try to ask yourself, is the number prime? Then all you have to do is say, well, what are the factors? If the factor is the number itself and the number 1, and those are the only factors, it's prime. That's it. Let me give you another quick number. We'll do this example later, but I want to give you a few examples up front. I'll give you another example of a prime number, 17. 17, the only way you can get 17 from your multiplication tables is 1 times 17. So it's prime because only 1 and 17 are the factors. I'll give you another one. Let's look at 19. 19 is prime. How do we know 19 is prime? Because in your multiplication tables, the only thing I can multiply to give me 19 is 1 times 19. That's the only thing that works. So because those are the only 2 numbers, 1 and the number itself, 19 in this case, then it's prime. So, right? There's other numbers. 13. 13 is prime. See, it's all these weird oddball numbers. 1 times 13 is 13, but that's it. So because those are the only 2 factors, 1 and the number itself, 13 in that case, it's a prime number. So 3 is prime because the only factors that actually that exist for 3 are the number itself and the number 1. So because of that, it's a prime number. So a composite number, you might guess, is all the other numbers except for the prime numbers. Composite numbers have lots of factors. 8 is a composite number because, 2 times 4 is 8. 1 times 8 is 8. There's other things that multiply that give me 8. 12 is a composite number. Why? Because 6 times 2 is 12, and 1 times 12 is 12, and so on. There are other things that multiply to give me 12. 24 is a composite number. Why? Because 6 times 4 is 24, and 1 times 24 is 24, and also 8 times 3 is 24. There's lots of things that multiply to give me 24. That's a composite number. So, big picture, the composite numbers are most of the numbers. Most of the numbers have lots of factors that multiply to give them. We call those composite numbers. But the special numbers are called primes. Those are the ones that only have those 2 numbers that multiply 1 times the number itself. Those are the ones that are the prime numbers with only those 2 factors like this. Now the next thing I'm going to show you is we thought about it in our mind how to find these factors here. I want to show you another way to find factors of numbers. It's going to be very helpful when we get to larger numbers, but I want to show you for the smaller numbers because it's really easy to understand, and also it's really helpful for when you get to big numbers. What if I ask you, tell me the factors of the number 84? Well, then you have lots of things to think about. What times what is 84? Lots of things to think about. So I want to show you a great way to find all the factors that's also very easy. So what you do is you go over here and you say, I'm trying to find the factors of the number 3. And you build what we call a little factor tree. Under the number 3, we try to think what times what is 3. And you can pick anything you want. I don't care what you pick. Anything times anything is 3. So in this case, there's actually only one combination. 1 times 3 is 3. So under the tree, because we're trying to find the factors of the number 3, we say 1 and we say 3. 1 times 3 is 3. And up till now in your math, we've been using the x as a multiplication, right? Because x means multiply. But x starts to get in the way. It's a big letter. And we use letters sometimes, when we talked about equations earlier. So I don't want to use the letter x all the time. So when you're doing these factor trees, I'm going to show you another way to write that things are multiplied together. We're going to put a dot right in the middle. You need to get used to seeing that. When you see a dot between two numbers or a dot between anything really, it means they're multiplied together. So I could put an x here, but it would mean 1 times 3. But the dot means the same thing, and you're going to see that more and more in math. So this means 1 times 3 is 3. Right, so you see the only numbers that work are these. These at the bottom of the tree are called the factors of the numbers. So we know what the answers are because this number is so easy, but we also can make this tree, which also can help us visualize what the factors of the number are. All right, so now I think it's time for us to move back to a different problem and get some more practice with figuring out. We want to, for these problems, write down the factors of the number, and we also want to write down, is it prime or is it composite? So let's find the factors of 10. The factors of 10. First, let's do it just by thinking through our multiplication facts, right? Well, we know that 1 times 10, we know that that equals 10. So the number 1 is a factor and the number 10 is a factor. We also know that what times what can give you 10? Think through your multiplication tables. We also know that 2 times 5, that can also be equal to 10. So we know that 1 times 10 is 10, 2 times 5 is 10, and actually that's it. So let's go ahead and write the factors down. The factors are going to be listing all these numbers here. The factors are the number 1, because 1 times 10 is 10. 2 is a factor because 2 times 5 is 10. Right? Then we go up, 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 up. Then we have 5. 5 is a factor because, again, 5 times 2 is 10. And then 10 is a factor because 10 times 1 is 10. So the factors of 10, I'll put the word factors here, are 1 and 2 and 5 and 10. Now this number, the number 10, has 4 factors. These are the numbers that can be multiplied together in any way throughout the listing there to give you 10. So we just go through the list. 1 times 10 is 10, it's a factor. 2 times 5 is 10, it's a factor. 5 times 2 is 10, it's a factor. 10 times 1 is 10, it's a factor. Notice that 10, which is the number itself, and 1 is always a factor of any number, because any number you think of, that number times 1 is itself. So let's think about 9. 9 times 1 is 9. Let's think about 12. 12 times 1 is 12. Let's think about 28. 28 times 1 is 28. So you always have the number itself and the number 1 as factors, like we have shown here, and also like we have shown here. But this one's prime because these are the only factors, the number itself and the number 1. This one is what we call composite. So we're going to write down composite, because it has more factors than that. It has the 10 and the 1, but it also has more factors. So anytime the number has more factors than the 2 that every number has, we call it composite. Now what I'd like to do is I'd like to show you how to figure this out with the tree method that I was going to show you. We're trying to find the factors of the number 10. So under here, I want you to tell me anything times anything is 10. I mean, don't pick 1 times 10. We know those are factors. What times what is 10? Well, 2 times 5. Remember, this dot means multiplication. Don't let that scare you. It's just a dot. Just picture an X there means multiplication. So what you do is you pick the number and you pick something times something is 10. We have 2 times 5. Now we could make the tree go down below a 4 and below a 5, but the only way I can write 2 is 1 times 2 under there. And the only way I can write 5 is 1 times 5. So when you get the tree down to the point where the only thing at the bottom is just, I can't really make the tree any deeper really, because the ones at the bottom are just 1 times 2 and 1 times 5, then I can just stop. And I can read the factors right off the tree. So the factors are read right off the tree like this. I know that 2 is a factor. I know that 5 is a factor. And then for every number, number 1 and the number itself is also a factor. So I always put those in the list. But all the other numbers, I can just read them right off the tree. Now you might say, why is he doing this tree business? It's so easy to think of this. Well, it's easy when the number is 10. But if I give you the number 96, it might be a little harder to tell me all the factors. So we're going to use these trees for the bigger numbers. I'm also going to show you here for the smaller numbers as well. So now that we know the basic idea, we're going to speed things up just a little bit. So what I want to find is the factors of the number 9. We're going to find the factors of the number 9. So we have to think through what times what is 9? What times what is 9? Well, I know that, of course, 1 times 9 is 9, right? Of course. 2 times, that doesn't work, is 9. But I get to 3, and I say, oh, I remember 3 times 3, that's equal to 9. Okay, and then I keep going. 4 times nothing is 9. 5 times nothing is 9. 6 times nothing is 9. 7, 8, none of those times anything is 9. So really, these are all the factors. So the factors of the number 9 are 1, because 1 times 9 is 9. 3, because 3 times 9 is 9. I'm sorry, 3 times 3 is 9. And then 9, because 9 times 1 is 9. Now I have 3 repeated here. When you're just listing the factors, you don't have to list all the repeated numbers. We're just trying to find the numbers that can be multiplied together to give me 9. So if I have duplicates here, I don't need to count them. So the factors of the number 9 are 1, 3, and 9. All right, now let me ask you a question. Is this number prime or composite? Well, it looks like it has more than 2 factors, so it has to be composite. So I'll put composite here. Right? See, the number 9 has always as a factor the number itself and the number 1. But it also has this factor, so it can't be a prime number. Because remember, prime numbers only have these 2 factors, the number itself and the number 1. Now let's go off to the side and let's do our little tree thing. We're trying to find the factors of the number 9. All right? So what do? I'm thinking, what times what is 9? Okay, so I'll build a little tree here. And I remember 3 times 3 is 9. So I'll put a 3 times a 3 there. 3 times 3 is 9. So when I read the factors off this tree, I just see that there's a 3 here. And I make sure and I put 3 in my list of factors. But in my list of factors, I always have the number 1. And I always have the number itself. So those, I don't really read them off the tree. The tree is used to tell me all the other factors. I know that 1 is a factor of 9. And 9 is a factor of 9 because 1 times 9 is 9. The tree helps me find out any other factors. So this is a composite number, and that is the final answer. All right, let's take a look at the next problem. Let's find, actually we've already done that one. Let's skip to the next one here. Let's do another one that's a little bit larger. Factors of the number 16. All right. So what we have to do is just think about what multiplies together to give us 16. Well, we all know that, of course, 1 times 16, that's 16. That's for every number. So the number 1 and 16 are factors. If these were the only factors, 1 and 16, it would be a prime number. But we know that we have more factors. So let's move up. Let's move up to 2. 2 times what is 16? 2 times 8 is 16. So 2 and 8 are also factors. Let's go up. 3 times nothing works to make 16. But when I get to the number 4, I remember that 4 times 4 is also 16. So 4 is a factor as well. Then I go to 5. That doesn't multiply to give me 16. 6 doesn't multiply. You might think 6 works, but 6 times nothing, it doesn't really work to give you 16. Then you go to 7. 7 times nothing is 16. Then you go to 8. 8 times, oh, I remember from my multiplication tables that 8 times 2 is also equal to 16. 8 times 2 is also equal to 16. So those are factors. And then I go up to 9, 10, 11, 12, and eventually I just can't find any more numbers that multiply to give me 16. So if I'm going to write the factors down, the factors of 16 are going to go like this. First, we'll have the smallest factor, which is 1. Then I'll write the factors in increasing order. 2 is a factor. And I keep going here. 4 is a factor. Yes, I know that I have the 4 written 2 times, but I only pick I don't count duplicates. And then I see that 8 is a factor. And again, see, I have a 2 here, but I already wrote 2 as a factor from before, so I don't write it again. So it's 1, then 2, then 4, then 8, and that looks like that's all that there is. So then there's 16, of course, that's a factor. So you see, factors of 16 always has a factor of the number 1 and always has the number itself as a factor. These numbers in the middle are the additional factors. The 2, the 4, and the 8, those are also factors because they can multiply to give 16. 2 times 8 is 16. 4 times 4 is 16, and so on, right? So, is this number a prime number or a composite number? Remember, prime number only has the factors that are the number itself and the number 1. This thing has tons of factors, so it's a composite number. It's a composite number. So what we will do is circle all of that because I want to list the factors of the number and I also want to list if it's prime or composite. Now you see, let's go off and write our factor tree here. We're going to write the number 16 and we're going to try to use it to predict the same factors here because it gets a little bit, you see how long it would take if I gave you, 59 or 58 or something and said, tell me the factors. You'd be thinking about it forever, writing all these things down. So let's look at it like this. When I get to this, I can build this factor tree any way I want. Let me first build it with anything times anything to give me 16. So let's think about 8 times 2. 8 times 2 is 16. I know that that's true. Now I can't really break the 2 any further because 2 is prime, right? Only 1 times 2 is 2, so I don't need to go any further there. But 8, of course, I can break 8 down further. 8 I can write as 2 times 4. 2 times 4. Right? And this 4, I can write it as 2 times 2. So you see what I'm doing? Is I'm just going down the tree and I'm breaking every number that I have into the smallest numbers that multiply. Now, of course, you can go as 1 times 2. 2 can go as 1 times 2. But when you get down to the point where the numbers at the bottom of the tree are just 1 times the number, then you don't really write them anymore. But 16 is 8 times 2. And then 8 can be written as 2 times 4. And then 4 can be written as 2 times 2. And I stop. And then I'm going to try to read these factors, the additional factors off the tree. So if I'm trying to write the factors of 16, I know that 1 is a factor. I know that 16 is a factor, so I write those down. But on the tree, I immediately see that 2 is a factor because it's at the bottom of the tree, so that has to go in there. I see that 4 is a factor, so that goes in there. And I see that 8 is a factor, so that goes in there. So basically, any numbers that you see in the tree, any numbers you see in the tree at all, you write them down as factors because it's called a factor tree. You're writing things down that multiply together to give you, in this case, 16. So any of these numbers are factors. Now I want to show you really quickly what would happen if you chose a slightly different tree. Let's do the exact same thing. 16. Instead of 8 times 2, let's say you did 4 times 4 because that also makes 16, right? Okay, so then you say, here's 4 times 4. All right, so this is 2 times 2. And this is 2 times 2. Remember, the dots just mean multiplication. So let's say I don't even have this as a factor tree. I want to use this factor tree to figure out the factors. So what do? I say, all right, 2 is a factor, I put it in there. 4 is a factor, I put it in there. But there's no 8 in this tree. So I'm like, what do? There's no 8 in that. So how do I find all the factors? So here's what you do. When you build your factor tree, all the numbers that are written there, you put in your list of factors. But also, any numbers in this branch of the tree over here, and any numbers in this branch over here, you can multiply branch to branch and it gives you even more factors. So you see I have a 4 here and I have a 2 in this branch. So I can multiply 4 times 2 and that gives me 8, and that's a factor. Right? Of course, this 4 times this 2 is 8, it's a duplicate. So what I'm trying to say is build your factor tree, and I'm going to show you lots of practice with it. And you write down all the factors that are in the tree. But then you also cross-multiply the branches here to here, here to here, looking for any more factors. Any other numbers you get by cross-multiplying the branches are also factors. You might say, well, it was much easier just listing them out. I agree with you. For the number 16, it's easier. But when I give you the number 96, it's going to be harder to think of all those things that multiply. So we're going to be using factor trees there. So no matter what tree you pick, what you actually end up doing on your paper, you will end up at all of the factors there. And of course, it's a composite number. All right, next we have to, I think we have 2 more problems. We want to list the factors of 13. All right, so we start thinking through it. What times what is 13? Well, I remember, of course, 1 times 13 is 13, right? And then what is 2 times something is 13? 3 times something is 13. 4 times something is 13. It doesn't look like anything else times anything can give me 13. So the factors are just 1 and 13. That's what I think the answer is. And because there's only 2 factors, the number itself and the number 1, this thing is called prime. It's a prime number. 13 is a prime number. So what we say is 13 is a prime number. And then, of course, we can try to do our factor tree. We'll put the number 13. Think of anything times anything as 13. The only thing I can come up with is 1 times 13. And then I have a 13 here, but I can't break that any further because, again, the only thing I can think of is 1 times 13. So the factor tree tells me the only factors are 1 and 13, which means it's a prime number. All right, I think we have, I was wrong, we have a few more problems. Let's take a look at the next problem. Let's take a look at the factors of the number 7. So we just go through our multiplication tables. We say, well, we know that 1 times 7 is 7. 2 times, oh, I can't think of anything as 7. 3 times something, 4 times something, 5 times something, 6 times, I can't think of anything else. So the only numbers are 1 and 7 that I can think of that multiply to give me 7, going through my multiplication tables. 1 times 7 is 7, and 7 times 1 is 7, so it goes in the list. Just like 1 times 13, so 1 goes in the list, and 13 times 1, so 13 goes in the list. All right? When I go over here, I know that 1 times 16 is 16, 2 times 8 is 16, 4 times 4 is 16, 8 times 2 is 16, 16 times 1 is 16, so all of them go in the list. But this one only has 2, so we say that the number 7 is prime. All right, 7 is prime. And if you want to do a tree, we don't really need to for this one, but all you would do is you would do 7 times 1. And I can't break them out any further. There's nothing else there, so there's only 2 factors, and that's all you have to say is that 7 is prime because there's only these 2 factors. That's it. All right, so let's go back to a larger number that you're going to be using a lot in math. The number 12 comes up all the time. Let's find the factors of 12. Let's find the factors of 12. All right, let's try to do it a slightly different way. Let's just go through our multiplication tables. Let's just try to write the factors down. We know that 1 times 12 is 12, so 1's a factor. Then we go up to 2. We know that 2 times 6 is 12, so 2 is also a factor. All right, 3. Let's think about it. 3 times something is 12. 3 times 4 is 12, so 3 is a factor. All right, then we go to 4, and we say, well, 4 times something is 12. 4 times 3 is 12, so that's a factor. Then we go to 5. 5 times nothing, that doesn't work for 12. We go to 6. 6 times 2 is 12, so that's a factor. 7 times something, 8 times something, 9 times something, 10 times something, 11 times something. None of those make 12. But then we get finally to 12. 12 times 1 is 12. So you see, you always have the 2 factors that are like the core factors. 1 times 12 is 12. The rest of these come from your multiplication tables. And I'll just, be 100% clear. We know that 1 times 12 is 12. We know that 2 times 6 is 12. We know that 3 times 4 is 12. So basically, we can get all the factors by writing down what multiplies to 12. 1 is a factor, then 2 is a factor, then 3 is a factor, 4 is a factor, and then 6 is a factor, and 12 is a factor. I've just listed all the factors here. All right, so how many factors do we have? We have a ton of them. Is this prime or composite? We know now that 12 is composite. Basically, if it has more than 2 factors, then it's going to be a composite number. So we circle that. That's our answer. Now, the last thing I want to do is go ahead and try it with the factor tree. Let's put the 12 here, and we're going to build this factor tree and see if we can recover all the factors, because when we get to larger numbers, we're going to primarily use the tree here. So you can do whatever you want, but the first thing that pops in my mind is 3 times 4. That's 12. Now, I can't really break out 3 because the only thing that works is 1 times 3, so you don't need to write anything. But under this, you know that 2 times 2 is 4. Now, I can't really break the 4's out, the 2's out anymore because only 1 times 2 is 2, so I don't need to write anything more. But this is a complete tree for the number 12, 3 times 4, and then 2 times 2. Now, again, I could do the tree a different way. Instead of 3 times 4, I could have picked 6 times 2 is 12. And it would be a slightly different looking tree, but it would get the same information out of it. So let's just use what we have here. What we have learned is that the number 12 we know has a factor of 1, and we know has a factor of 12. All we want to do is figure out from the tree anything extra. So we can see that 2 is a factor, we can see that 3 is a factor, and we can see 4 is a factor. We read them all out of the tree. Any number you see in this tree is a factor, 2, 3, and 4, right? But look at this, the number 6 we know is a factor, but it's not in the tree. But I also told you, extra factors you can get by multiplying the different branches. Any number in this branch times any number in this branch. So here we have 3 times 2. 3 times 2 is 6, so 6 has to be a factor, right? 3 times 4 is 12, but we already know 12 is a factor, so we can put that up there as well. But we know we can get an extra factor by looking at 3 and multiplying by one of these 2, so 6 is a factor, and look at that, we already had it in our list. So the tree can be used to give me all those extra factors. I'm trying to teach you for the small numbers, because for the big numbers, it's going to really save us, actually, a lot of time. So the factors are 1, 2, 3, 4, 6, and 12, and it's a composite number. Let's take a look at the factors of the number 22, the factors of the number 22. Let's first just try to do it by thinking about the multiplication tables. Well, we always start with the number 1. 1 times 22 is 22, so we know that's right. We go to 2. Okay, 2 times what is 22? 2 times 11, so we know that 2 is a factor. We go to 3 and 4 and 5, and we don't find anything else that multiplies to give us 22, but eventually we get to 11, and we know that 11 times 2 is 22, so that goes there. And we keep going up and up and up, and nothing else multiplies to give us 22 until we get to the number 22. So we know that 1 times 22 is a factor. 2 times, so 1's a factor. 2 times 11 means 2's a factor. 11 times 2 means 11's a factor. 22 times 1 is there, so we know it's a factor. So if you really want to multiply it, we know that 1 times 22 is 22. We know that 2 times 11 is 22. So really all the information's here. 1 is a factor, 2 is a factor, 11's a factor, and 22 is a factor. Right now, is this a prime or composite number? So we know from this that this is then a composite number. So I'll just write it, I guess I'll write it over here. I'll just write it right here, composite. Composite number, right? All right, so then let's try it with our factor tree. We want to look at the number 22. So you can pick anything you want. The first thing that pops in your mind that multiplies to give you 22. For me, it's 11 times 2. I know that's 22. Then I try to break these down further. For 2, there's only 1 times 2, so I can't go any further. And for 11, the only thing that works is 11 times 1, so that I can't really go further there. So my tree is done. So I know that the number 1's a factor, and I know that the number itself, 22, is a factor. So I look in the tree for other ones. I see that 2 and 11 are factors. And then, of course, I told you I can multiply branches. You're going to get 22 here, and that's already in my list. So there's nothing left to do. There's no other factors. You see, 22 is kind of a big number. You have to go through all of the numbers and try to think through your math facts. But if you write a tree like this, it's actually easier because you just read things right off the tree, and then you cross multiply branches to find extra factors. So these are the factors, composite number there because it only has, it has 4 factors. And so that is the gist, that is the main thrust of this lesson. Firstly, I want you to understand what a factor is. It's just a list of numbers that we can multiply together to give us the number we're talking about. If we only have 2 factors, the number 1 and the number itself, we call it a prime number. Any other number with any other factors other than those are what we call composite numbers. Then we can find the factors by just thinking through the multiplication tables, but we can also find the factors by writing what we call a factor tree. So what I'd like you to do is go through these yourself. They're pretty small numbers. I would really like you to do them yourself so you make sure you understand what's going on. Follow me on to the next lesson. We have several lessons to practice this concept and build your skills step by step. Learn anything at mathandscience.com.